Today we'll be doing exercise 2.2 from the chapter Polynomials of Class 9 NCERT Mathematics. So let's get straight to it. Question 1 of the exercise says find the value of the polynomial 5x minus 4x square plus 3 at the following points. The first one being x equal to 0. So here we will replace the value of x as 0 in the above polynomial and we get 5 into 0 minus 4 into 0 square plus 3, which brings us to 0 minus 0 plus 3, which is equal to 3. The second part is find the value of the polynomial at x equal to minus 1. So here we will replace minus 1 in the above polynomial, and that brings us to 5 into minus 1 minus 4 into minus 1 whole square plus 3. This gives us minus 5 minus 4 into 1 plus 3, which gives us minus 9 plus 3 or minus 6. The third part is asking us to find the value at x equal to 2. So replacing x with 2 in the above polynomial, we get 5 into 2 minus 4 into 2 square plus 3. This gives us 10 minus 4 into 4 plus 3, which gives us 13 minus 16 or minus 3. And these are the values at the respective points that the question is asking us. Moving to question number 2. The question number 2 is asking us to find p of 0, p of 1 and p of 2 for the following expressions. The first part is p of y is equal to y square minus y plus 1. So for p of 0, we will replace y with 0 and we get 0 square minus 0 plus 1, which is equal to 1. Similarly, for p of 1, we will replace y with 1 and we will get 1 square minus 1 plus 1, which is equal to 1 again. P of 2, we will replace y with the number 2 and we get 2 square minus 2 plus 1, which is equal to 4 minus 2 plus 1, which is equal to 3. And that's the first part. The second part is p of t is equal to 2 plus t plus 2t square minus t cube. Now here, to take out p of 0, we will replace t with 0 and thus the expression becomes 2 plus 0 plus 2 into 0 square minus 0 cube, which becomes simply 2. P of 1 in this polynomial will be replacing 1 with the variable t, and hence we will get 2 plus 1 plus 2 into 1 square minus 1 cube. This gives us 2 plus 1 plus 2 minus 1, which gives us the number 4. Similarly, p of 2 in this case, we will replace 2 with t and we get 2 plus 2 plus 2 into 2 square minus 2 cube. This will be reduced to 2 plus 2 plus 2 into 4, which is 8, minus 2 cube, which is minus 8. And the answer is 4. The third part of this question is p of x is equal to x cube. Here, like before, for p of 0, we will replace x with 0. We get 0 cube, which is 0. P of 1 will be 1 cube, which is 1. P of 2 will be 2 cube, which is 8. Moving on to the fourth part. The fourth part is p of x is equal to x minus 1 into x plus 1. Now, I can rewrite this expression as x square minus 1 square, or simply x square minus 1. Just simplifying this expression into this one. And now, to get p of 0, I will replace 0 with x square over here, and I get 0 square minus 1, which is equal to minus 1. P of 1 becomes 1 square minus 1, which is 0. And p of 2 becomes 2 square minus 1, which is equal to 3. And that's the solution for question number 2. Question number 3 is asking us to verify whether the following are zeros of the polynomial indicated against them. Now, just as a reminder, a zero of a polynomial is that value of the variable at which the polynomial equates to 0. So let's look at the first part. In the first part, the polynomial is p of x is equal to 3x plus 1, and the value to be verified is x equal to minus 1 by 3. So now, in order to check, or in order to verify that whether this value of x is the zero of the polynomial, we will substitute the value of x in this polynomial and see what it equates to. So replacing x with minus 1 by 3, I get 3 into minus 1 by 3 plus 1. This gives me minus 1 plus 1 is equal to 0. So the polynomial equates to 0, which verifies that indeed x equal to minus 1 by 3 is a zero of this polynomial. Moving to the second part, here the polynomial is p of x is equal to 5x minus pi, and the value to be verified is x equals to 4 by 5. Now again, we will replace the value of x with 4 by 5, and we get 5 into 4 by 5 minus pi. This gives us 4 minus pi. 4 minus pi is not equal to 0, and hence this means that x equal to 4 by 5 is not a zero of this given polynomial. The third part of the question, the polynomial is x square minus 1, and there are two values of x given to us. X is equal to 1 and minus 1. So here, let's try x equal to 1 first. So this brings us 1 square minus 1 is equal to 0. And the other value of x, p of minus 1, here we have minus 1 square minus 1, which also gives me 1 minus 1 equal to 0, which means both x equals to 1 and x equals to minus 1 are zeros of this polynomial out here. The fourth part has the polynomial p of x equals to x plus 1 whole into x minus 2. And the given values of x that we need to verify is x equal to minus 1 and x equal to 2. So at first, we'll check for x equal to minus 1. This gives us minus 1 plus 1 into minus 1 minus 2. This gives us 0 into minus 3, which is equal to 0. P of 2 is 2 plus 1 into 2 minus 2, which is 3 into 0, also equal to 0. So for both these values of x, x at minus 1 and x at 2, this polynomial equates to 0, indicating that both these numbers are the zeros of the given polynomial. The fifth part of the question has the polynomial p of x equals to x square, and the given value of x is x equal to 0. Here, replacing x with 0, we get 0 square, which is equal to 0, indicating that yes, indeed, x equal to 0 is the 0 of this given polynomial. Moving to the sixth part. In the sixth part, the polynomial p of x is equal to lx plus m, and we need to check for the value of x equal to minus m upon l. So we'll replace this value in the polynomial. This gives us L into minus m by L plus m. This gives minus m plus m, which is equal to 0. And this means that this value of x is a 0 of this polynomial out here. Moving to seventh part of the question. The polynomial is p of x is equal to 3x square minus 1. And here the values of x that we need to check is x equal to minus 1 by under root 3 and 2 by under root 3. So let's start with first one, which is minus 1 by under root 3. We'll replace it for the value of x. This becomes 3 into minus 1 by under root 3 whole square minus 1. This brings us to 3 into 1 by 3 minus 1. This is 1 minus 1, which is equal to 0. Second one being p of 2 by root 3. Replacing x with this constant, this value, we get 3 into 2 by root 3 whole square minus 1. This gives us 3 into 4 by 3 minus 1, which gives us 4 minus 1, which is equal to 3. So in this case, here x equal to minus 1 by root 3 is a 0 of this polynomial. However, the second value 2 by under root 3 is not a 0 of this polynomial. The eighth part of this question is p of x is equal to 2x plus 1, and the value of x that needs to be checked is 1 by 2. So p of 1 by 2 is equal to 2 into 1 by 2 plus 1, which gives us 1 plus 1 equals 2. Hence x equal to 1 by 2 is not a 0 of this given polynomial. Now moving to question number 4. Question number 4 is asking us to find the 0 of the polynomial in each of the following cases. The first part is p of x is equal to x plus 5. Now to find the 0 of the polynomial, I'm going to equate this polynomial to 0 and find the value of x. So in this case, when I equate it to 0, it becomes x plus 5 is equal to 0, or x is equal to minus 5. So x equal to minus 5 is the 0 of this above polynomial. Second part of the question is p of x is equal to x minus 5. Now in this case, when I equate this polynomial to 0, my value of x comes out to be 5. So at x equal to 5, this polynomial will become 0, which means x equal to 5 is a 0 of the given polynomial. Moving to the third part. The third part, polynomial is p of x is equal to 2x plus 5. Now here, when I equate this polynomial to 0, I get 2x is equal to minus 5, or x is equal to minus 5 by 2. So when x is equal to minus 5 by 2, this above polynomial becomes 0, which means x equal to minus 5 by 2 is a 0 of this polynomial. The fourth part is p of x equals 3x minus 2. Again, I will equate this polynomial equal to 0, and my value of x comes out to be 2 by 3, which is a 0 of this given polynomial. Moving to the fifth part of the question, p of x is equal to 3x. So when I equate this to 0, I get x equal to 0. So x equal to 0 is the 0 of the above polynomial. The sixth part is p of x is equal to ax, and it's also said that a is not equal to 0. So when we equate this to 0, this becomes 0 by a, which is equal to 0. This is equal to 0 because I know that a is a non-zero number they've given us over here. So again, at x equal to 0 is a 0 of this above polynomial. Moving to the seventh part. Here, p of x is equal to cx plus d, and they've mentioned that c is not equal to 0 and c and d are real numbers. Now we'll equate this polynomial equal to 0. This gives us cx is equal to minus d, or x is equal to minus d by c. Now at this value of x equals to minus d by c is a 0 of this above polynomial in part number 7. And that brings us to the end of this exercise. Thank you for watching this video. If you have any questions or any concerns, please leave a comment below or reach out to me in the email ID mentioned in the description. Thank you once again. I'll be back for the rest of the exercise in following videos.